Hello everyone, it's Sebastian speaking, and I'm happy to be back because I have like an interesting subject maybe for you guys who wants maybe to collect some IMSIs, for example, to maybe track your neighbor or and so on, but maybe also to do some research. I mean, looking at some frames that are going to the base station, but also going from the base station. So this is like a nice trick, I mean, a nice tool that was released recently, and we'll speak about that. Before we start, I wanted also to talk to you about Hardware I/O, and it will happen in a month. So we will have the opportunity also to meet each other there. And if you're interested about everything about hardware stuff, wireless stuff, I mean, this is the event to go. And also, I'm teaching a class there. So if you're interested about SDR, how we can reverse engineering some signals there, I mean, you're welcome. And let's go. So today we'll speak about a project that was released 2 days ago, which is called LTESniffer. So LTESniffer is actually the first open source tool that allows you not only to inspect for downlink frames, so the frames that are coming from the eNodeB, for example, in LTE, but also the uplink. So you can actually eavesdrop the downlink and the uplink. But it will require us some tools to do that. Yes, of course, we'll have to actually use, for example, sorry about that, we'll actually have to use this guy, which is USRP X300, not 310, because yeah, of course, the documentation tells you that, the prerequisite to do that is to use actually the USRP X310, but actually, X300 will be enough for that. I'm reassuring you. So let's now go forward and see how we can actually play with that. So what we'll do is that first we'll start this little guy. So let's start it. It will create a lot of noise, and then we'll just like see how we can actually configure all the stuff. So the first thing we will do is that we will have to warm up the GPSDO. So like that, we'll be sure that the symbol will be well synchronized. So let's do that, for example, with the query GPSDO sensor, and maybe it will take a little bit of time in order to acquire to be locked. So for the moment, you can see that the status of the GPS is still off because the LED is off in here. So as soon as we will get all the ephemeride for that, then we'll be able to fire the project. And now it's fine. You can see the light is up. So now we'll just request once again GPSDO sensors and see that we are able. Everything is fine. GPS and UHD device time are aligned. When it's done, we will have to do some tuning in here because, for example, if we are just like trying to benchmark everything in here, so there was a tool in there called benchmark. I have actually just pulled the latest UHD sources as mentioned in the Git repository. And then I would just like do some benchmark in order to see if everything is going fine in there. So let's just call benchmark like that. I'll probably just go to host build example benchmark like that, and then try to benchmark these things. So benchmark. I will actually use the lines that I've copied in there. Okay. And so let's see, but we will have to tune things a little. Yeah, actually this is not super good. Okay, now let's tune it a bit. So we'll just first, for example, just use the 8 tool like that. I don't remember the interface that I was using because it changed a bit since back then. I'll just copy my lines in here and use the new ones in there, like that. So up, up. Then also look at the CPU frec, and I will also raise the MTU. So we have conservative on the mode, performance. So we will just like use performance mode in here. Also, but let's just put all the CPUs in performance mode. And then I will just use the sysctl in order to increase a little bit the write memory in here and read memory. And also I will increase the MTU. So I will use once again, no, I will use ifconfig for that directly. So up MTU, and the MTU that is suggested is, yeah, of course, this one. So, like that. And normally, if we benchmark everything now, we have less issues. So we're just preparing to receive a rate of 200 megasample per second. We've been using 2 channels, and you see no errors in there. Perfect. I mean, normally perfect. So now let's go on the project in there. So you may guess that maybe using directly this project will work. So let's maybe just go projects like that and see the different modes that they propose. So we have different modes like I mean, everything is in there is installed, so you have to follow everything in there. And we'll test the downlink sniffing, right? So let's test it. But the thing is that the frequency that I will use in there must relate something that I will probably see in there. So for that, there's a simple way to actually guess it. You can actually use different tools. Like, for example, there's a tools that you can use, like, for example, radio, build mobile, yes, as run 4G that I've prepared in there in this computer. And normally you can go to libraries, examples, then, sorry, build like that, up, SCS, lib, samples, up, search. Let's maybe just use the 7-band like that. We can directly use our USRP to do that, and then we can scan for some RFCN, right? Once we have found any RFCN, we can actually do something interesting. So we'll be able to inspect them. Frequency band up. You will see that it is related to the downlink. This downlink, exactly. Where is that for the moment? Yeah, we see that the power of the PSS is quite low in here. I mean, also where I'm living, there's not a lot of coverage, so it will be like a little bit a pain to retry everything, but yeah, let's go. I will go now to the LTESniffer project, build. I have built everything in there, and then I can actually just save it and use the downlink, this magic line. But this magic line is not very magic. I mean, it will just tell Wireshark LTESniffer to use 2 antennas and 4 workers. So you can also increase, for example, that if you want to use more workers. If you want to use just 1 antenna, you can also use 1 antenna. And here we will have to actually use the frequency that was detected in here. Up, megasample in megahertz. The .c in there just tells to the tool to just also perform some cell scanning around, and then the mode tells if we are doing downlink or uplink. So let's just do some downlink things. Okay, so you see this is like an invalid pointer. Of course, you probably don't want to use an old Ubuntu system or reinstall your computer with an old Ubuntu system. So that's why also Docker is for, right? So I've made a Docker container for you, which allows you, for example, to directly use the tool. And also what we will do is that we will use a frequency that is actually working in here in this specific area. Because of course, in here, if I am just like binding a phone, the phone will directly use, a frequency that is actually good to operate, right? So I'm just using the service mode in here in order to see on which frequency my phone is, and then I can move forward using the tool like that. Let's use the tool, and now we will capturate the downlink. So let's cross fingers. Okay, so here you see there's one NRTI that has been detected. Perfect. It looks promising. In here, you can see that, for example, some frames or some subframes have been processed and also passed, as we may guess. So normally we should then use, the Wireshark tool in order to see if something happened, at least. Okay, so now let's maybe choose one of the cells that has enough power actually to sniff something. We see that this one is actually a good match, right? So let's maybe just like save it after, like that. And then we can just, I don't know, I will also maybe just save this one, just in case. That, like that, and maybe this one. This one is still good enough, because the other ones are probably maybe too weak. So yeah, let's maybe just like use these, and then we can just use the tool against it. So you have two choices. You can actually, for the downlink, you can use, for example, the M argument like that, the frequency that you will choose, and then there will be like the number of workers, the number of antennas. So you can also use one antenna, one worker. You're able to choose whatever you want. So for first, what we'll do is that we will convert, one of these values that we have found to frequencies. So to do that, there's a nice tool, and we can use, for example, copy in there like that, and we can just like copy this frequency up. Don't, remember that we have also to precise that we are working in megahertz, and then we have to precise also option C to scan, to make the scanning work. So let's just go to the sniffer, build, and normally it should be good like that. So searching for cell IDs, automatically it has detected the cell ID 2, which was actually one that was actually displayed in physical ID, right? But for the moment, we don't have like a lot of things. It's maybe because maybe there's like not a lot of traffic, but also maybe because also the the cover is not good in here. So maybe I will use another ARCN, which will be probably better. So let's go with that. Also, yeah, I didn't notice, but the frequency is in there. But then we will use actually the table that is in here to calculate directly the uplink. But there is also some formulas for that. We can use, for example, the formulas in there. So let's just use this one instead, and you will clearly see the difference. So normally we have the physical ID 296, and normally we should have something much more relevant. Okay, so as you can see now we have something, and this is because actually, I mean, the PCS power was actually very low in here. So, I mean, after that, you can scan, a lot, and then you can actually then, after that, recover the pcaps that have been generated. So yeah, I would just because I'm lazy and I don't want to actually remount the Docker with a shared disk. I mean, I will do like something that is, maybe not good, or I mean, that's hacky thing, right? And I will just recover everything in there, DL, and then look at what I get, and I see some system information in there. So of course you will have also to get that, you will have to configure the DLT users. I mean, this exercise is left for you. And I mean, then you can inspect a lot of things. Like, for example, we can maybe inspect for, let's say, maybe TMSIs on PG records. I mean, STMSIs. So yeah, we have pretty much a lot of things. That's cool. So yeah, in this particular cell, we see something. But yeah, maybe it should be also interesting to see what is going on the uplink, right? So for the uplink, you can also, as I said before, you can calculate using a table like this one. You can just use this uplink in megahertz. Also, we'll just drop the scanning features, and we just will go directly to the MIT and use the PCIe that is exposed in here, which is 296, and with a PRB of 50, as you saw before. So then we will use the uplink frequency of this amount, and then we can actually, sorry for that. I forgot also to use the option for uplink, right? All right, let's see. We still have some invalid RGBs, but we can actually see, for example, that there is some context RNRTI that is shown up, and SCNR, and something is actually doing there. So for the moment, looking at the context, we don't know yet what are the max. Is the NRTI capable of 16 QM or 64 QM or more than that, as said before? But maybe we'll have at least some context to actually talk about that. Talk about what is going on. So yeah, for the moment, it is not complete, but yeah, you will have time for that, right? So you can look at the UL, and on the UL side, you can see the paging records that are sent by the UE. And so you can also see error connection setup. So we'll have actually some identities in there. And so yeah, as you have guessed, for example, if you're looking to TMSI, you will see that, for example, for this context here, this NRTI, you see MTMSI in there, like that. I don't think we will actually see any IMSI. We didn't scan too long for that, but scanning a little bit further than that would probably help. What is also interesting with this tool is that this tool is providing you with some nice options, like for example, that option. We can actually look at all these options. You have the APA mode for 0 for identity mapping, 1 for IMSI collecting, 2 for UE capabilities, and 3 for all. I prefer to use 3 for all. That will be good, right? And so then we can actually observe some detected identities. Like for example, we have for this NRTI, we have this TMSI and so on. I mean, this is the TMSI that you will actually look at it in here. But what is cool with this tool is that you will not have to grab them from the pickup. I mean, you can always make a tool to grab them from the pickup. But I mean, it's this kind of tools allows you maybe to give you some ideas of what is possible to do directly with these tools. For example, tracking some users. Maybe also look at capabilities of the UIs. Looking also on the capabilities that are used, for example, by the cell. I mean, look at some security features. There's like a lot of possibilities, right? So, I mean, you should not be just restrained by these tools. You can also, make your tools around this one because now you can see the possibilities of this one, but also you see that, to make it much more stable, always look at, for example, the right antennas, the good coverage, and generally for that, also for the antennas, you use, for example, network vector analyzer that will help a lot. But yeah, in here, for example, we have some interesting results, but as you could see also before, with another cell, it was not the same case. For example, for the previous case, with the previous cell, we didn't have any result in here, and so we couldn't retrieve anything important. So, if you consider using a USRP B version, consider maybe using the 210 version. This is the one that also the creators recommend. But let's see what it's possible to do with the B210 version and what is not. So first, we'll actually do the same. We'll just use, for example, first the downlink option for now with 2 antennas. So the B210 has actually 2 antennas, RX antennas. So I would just also look at the antennas in here. The antenna are well used. Let's see. So we get pretty the same result, right? Like that. So that is interesting because you don't need to actually buy also, for just the downlink, you don't need to buy the X210. But if you want to do the uplink, that will be complicated with this one actually, because in here with this USRP, if you want to also look at the uplink, you will need the downlink to actually decode these subframes. But before getting the uplink information, you need also something called a MCS table, which is a modulation coordinate scheme, and that could be only retrieved having also metadata, which is called a DCI, which is the downlink control information metadata, and that can only be retrieved with downlink. And then having this DCI metadata, you can have an MCS index that allows you then to decode the information, but you cannot retrieve the total table, the total MCS table. So because this table will be encrypted also during the communication. So the tool is actually doing some sort of brute forcing, and this is quite good. Everything is written on the paper. Also, you can look at, for example, if you have time. And the paper is very interesting because it allows you, for example, to understand why you have such a limitation, and also what were actually the challenge of doing these tools. And this is something to consider, because of course there was some tools around, for example, SS Run and so on. But there was also some commercial tools. And what is interesting is that also these tools implement a lot of things compared to previous tools, like for example LTEI, OWL, Falcon, L-Scope, WaveJudge, and so on. So I've been using, for example, some of the tools like Falcon and OWL, and I should say that these tools didn't provide as much information as LTESniffer that you can see in there. So basically, it's a nice tool to use because in here, particularly, you have, of course, it's open source. Not only that you can do the DL on the control link, but you can also do the you can also have information on the data channel, and the UL data channel. So this is something that actually OWL and Falcon couldn't do. And so you had to actually, use SS1 to get some data channels information as well, or to buy AirScope, which is was still expensive, but less expensive than other tools as well. There's like a lot of potential in this tool. You can scan for TMSIs, MSIs. You can also look at capabilities. You can also, take a look at a lot of things, in a very low level with that. What is also interesting is that, and this is also why this kind of tool can be relevant, is that you can also, for example, try to replay some of the research that have been before by David Rieprich and also these teams. And this is the kind of paper that you should maybe consider also to replay if you have this kind of setup and this kind of tool, because also they actually also use AirScope at the beginning to observe, to make some observations. But now with LTESniff, you can go, you can go further. You can also inspect to, for example, the exchange that have been made. You can do like a lot of things in a very low level, what is cool. So yeah, basically today you have all the tools, but there's a but. You have to consider having, a setup that will match this kind of tool in order to make it work properly, and also look at the coverage. At the end, the radio is completely messed up at the end. So this is also a kind of disorder you will have to resolve yourself. But this is also a kind of disorder that I'm also teaching you to manage. And this is the end of this video. I hope you like it. Don't hesitate also to subscribe and also to thumbs up. So like that, you will encourage it. I will also come back with other subjects. I have a lot, a giant stack of subjects for you. And I wish you guys, a nice weekend. If we have the chance also to cross each other during Hardware I/O, I'll be happy also to talk with you between beers. And yeah, thank you very much, guys. See you later. Bye-bye.